we are starting chapter 6 today. I apologize for that saying lesson 8 point because this is actually chapter 6. But I want you to start by looking at the paper that says interior angle sum of polygons. We're going to kind of derive the formula for how to find the sum of the interior angles of a polygon. So at the bottom of your paper, I have this chart. And I want you to look at the number of sides of a polygon. So a three-sided one up here is our triangle. The n is the number of sides, it has 3. So it has 3 sides. What are the fewest triangles inside the polygon? So in order to be a triangle, you have to choose one corner and draw a line to its vertices. Vertices are the endpoints, and see how many triangles fit. This only has 1. So in a 3-sided shape, you can only fit 1 triangle in there. And we know that the interior angles of a polygon, if it's a triangle, measure 180 degrees. And we know that because we've already learned about triangles. Let's move on to a 4-sided shape. So for this 4-sided shape, I've already drawn little dots to show you the vertice I want you to go from. Draw a line that would make another triangle inside here. So obviously don't go to this edge because that's already there, and don't go down here to this edge because that's already there, but there isn't a line to this vertice. So let's go ahead and draw one in. So now that we've drawn in another line, how many triangles could we fit inside this 4-sided shape? We have been able to fit 2 triangles in there. So this would be 2 triangles. And do you know the number of degrees inside a 4-sided shape? I think we've talked about this before, but there are 360. All right, so let's try the 5-sided shape. Going from the dot that I darkened in, draw a line to each vertice besides the 2 that it's already connected to. So you can draw a line down to here and to over here, and that makes 3 triangles inside. And the total amount of degrees in a 5-sided shape is, I'm not sure if you guys know this or not, but it is 540. So I'm going to let you in on a little secret here. Each triangle measures 180. So you can take 180 plus 180 plus 180. So 180 plus 180 plus 180. And that's 540. So 180 in this one, 180 plus 180, which is 360 in this one, and 180 plus 180 plus 180, which is 540 in this one. And it continues. So the number of sides are 6. How many triangles can we fit in there? 4. 4 times 180 is 720 degrees. Let's keep going, or you can push pause on the video and try the rest yourself until we get done with this chart. I'm going to go a little bit, I missed one, faster. I know that this is going to be 1, 2, 3, 4, 5. And another 180 added to my 720 is 900. And I'm going to actually stop drawing in triangles, and I'm just going to continue this table because it is a pattern. 1, 2, 3, 4, 5, 6, 7, 8. Oh, this skipped 11, so be careful here. So we're going to skip 9, and this would be 10. Okay, and we're going to add 180 to each of these. So this would be 1080. 1080 plus 180 is 1260, plus another 180 is 1440, and then plus another 180, oh, I forgot we skipped 11, so plus another 180 is 1800. Okay, this little chart that we're filling out is going to come back to help us derive the formula for any n number of sides in just a minute. So let's turn the page and look at the next part. This is where it actually talks about the polygon angle sum theorem. So I want you to know 3 different types of polygons for today. So one is an equilateral polygon. Equilateral, when you see the LAT, that actually refers to the sides. So those would be things you could put little hash marks on. So this length, if we measured it, maybe it'd be, I don't know, 3 centimeters. And so this one would also be 3 centimeters. And so would this one, and so would this one, and so would this one, because they're all marked up showing that they have equal sides, which is equilateral. Okay, then you could have an equiangular, which that sounds exactly like what it is. It's talking about the angles. So equiangular means if this measured 120 degrees, then this would be 120, this would be 120, this would be 120, and so on, because they're all marked with equal little arcs, showing that they all have equal angles. And then the last one is called a regular polygon. So any regular shape has both equal angles and equal side lengths. So this is equilateral and equiangular. That would be called regular, and it would have to be for every single one of its side lengths and every single one of its angles. Okay, so knowing that, we'll get back to practicing some of those later. Let's go back to the idea that we did right down here, figuring out all of these different degrees. So that brings us to this theorem, polygon angle sum theorem. The sum of the measures of the interior angles of any shape, an n-gon, is n minus 2 times 180. So let's take a look. The number of sides minus 2 times 180. The number of sides minus 2 is 3 times 180. 6 minus 2 is 4 times 180. 7 minus 2 is 5 times 180. So what we did was we figured out the number of degrees. We figured out the equation. The number of sides in a polygon, subtract 2 from it first, and then multiply that answer times 180, and that will be the number of degrees. So they've given us an example. They said, what about a heptagon? And I'm not sure if you remember what a heptagon is, but it's a 7-sided shape. So they have taken 7 and put it in for n. 7 minus 2 is 5 times 180, which is 900. So let's try the got it's. What is the sum of a 17-gon? So that's going to be 17 minus 2 times 180. And you're just going to use your calculator. So 17 minus 2, I know you could have done that part in your head, 15 times 180, 2,700. That means there are 2,700 degrees in a shape that has 17 sides. All right, and then let's try the got it 1b, reasoning. The sum of an interior angle measures of a polygon. Okay, so now it's going backwards. Now it gives us that it equals 1980. How can you find the number of sides? Well, if this is our equation, we're just going to set it equal to our total, which they said is 1980. So we're just going to set up this equation, n minus 2 times 180 equals 1980, 1980, and we're just going to solve it. I would first need to divide both sides by 180 to get it to cancel. And then I'd have n minus 2 equals whatever 1980 divided by 180 is, 11. I would add 2 to both sides. You're just solving an equation. This is where algebra comes in handy. That would be a 13-sided shape. Okay, let's continue to the next page. This is, this is now moving on to the interior angles of any shape. Let's say it's like a, one of these eyes of like a bee. I think it's a bee. I'm not actually sure. Let's read it and we'll see. It's a housefly. The common housefly has eyes that consist of approximately, this is hard to see, 4,000 facets. Each facet is a regular hexagon, like that you can see in this picture here. What is the measure of each interior angle of one hexagonal face? Okay, they have actually worked this out for us, but I want you to see why. They took n, which is 6, because we're talking about a hexagon, and they substituted here 6 minus 2 times 180, and then divided by 6 because that is one angle. So again, it was asking us for one of the angles, so one little part right here. So you're just taking the total and dividing by the number of sides there are to get the one angle measure in here. Okay, So let's try one ourselves. So what if it's a regular nonagon? So a nonagon is a 9-sided shape, so 9 sides. So we are just going to do n minus 2 times 180. Oops, didn't mean that one. And then divide by 9. So 9 minus 2 is 7. 7 times 180 is 1260. Divided by the number of sides there are, this will give us the measure of one of those angles. So if it's asking for just one angle, divide by the number of sides there are, which is 140 degrees. So one angle would be 140 degrees. All right, let's look at the last page of lesson 6.1. So this one is now using a polygon angle sum theorem. So they want to know, what is just the measure of angle y? So this is the only one we don't know in the pentagon today, T-O-D-A-Y. So what you do is add them all up, just like they did here, and then they're doing it with algebra, but really, if we know that a 5-sided shape is going to measure 540 degrees, it's also on the front here. A 5-sided shape measures 540 degrees. So if we know that it's going to measure 540, you could just do 540 minus 150 minus 120 minus 90 minus 110, and that would be what's left, which is basically what they did. They just did it a little fancier way with algebra. Let's try this got it right here. What is the measure of angle G in this EFGH quadrilateral? So a 4-sided shape, if you're not sure, has 360 degrees in it. So we are just going to take 360 and we're going to subtract 120, 85, and 53. 120, 85, and 53. And again, this is not the only way to do it. We could add these and set it equal to 4 minus 2 times 180. I mean, there's definitely more ways to do this. I'm just trying to think about the easiest way. So 360 minus 120 minus 85 minus 53 is 102. So that means this angle measure would be 102 degrees. All right, and then the last thing we're learning today is actually about the exterior angles. So all day today we've talked about, or this whole lesson, sorry, today we've talked about the interior angles, all these angles that are inside, but now we're looking at the ones that are on the outside, and this is how I want you to see it. The outside of this angle continues on. It's an extension of that line if it were to keep going, and that's how you get your external angles. The exterior angles, I'm sorry. So here's the thing that you need to know. Exterior angles of any polygon at all, I don't care if it's a triangle, a quadrilateral, a hexagon, a nonagon, all of them add up to 360 because every one of these is going in a circular fashion and a circle is 360 degrees. So whether it's a triangle and you're adding the angle measures outside here, or if it's a pentagon and you're measuring these outside, or whether it's a an octagon and you're measuring the external ones, it doesn't matter. They would all add up to 360 every time. I don't care what shape it is. So it's 360 divided by the number of sides, and that gives you each angle measure out here. So let's take a look at problem 4, finding an exterior angle measure. So if we know that it's an octagon and it has 8 sides, you're just taking 360 divided by 8, which is 45. So that means every single one of these would measure 45 degrees. Okay, so what is the measure of an exterior angle of a nonagon? Nonagon, again, is a 9-sided shape. So we would just take 360 and divide by 9, which is 40 degrees on each exterior angle. Okay, I think I told you that we were done after this, but I think we have one more. I'm actually going to have you try 4, 5, and 6 on your own, but let's do the do you know how together, these 3 at least. So number 1, what is the sum of the interior, so we're switching back to interior, angles of an 11gon? Okay, interior angles is n minus 2 times 180. So if it is an 11gon, it's 11 minus 2, which is 9, times 180. 9 times 180. 1620 degrees. 16. Okay, that's the sum of all the angle measures. What is the sum of the exterior? Oh, exterior this time of a 15. So, well, the sum of all of them are always going to be 360. So I don't care if this said 15 or if it said 100 or it said 2 or if it said 20. It doesn't matter. The sum of the exterior angles is always going to add up to 360 degrees. That was a tricky one. If it said one of the angles, we would need to divide by how many there are, but it doesn't matter that it's 15. All exterior angles add up to 360. Okay, and then the last one we're going to do together today, find the measures of an interior angle. So just one interior angle and an exterior angle. So just one of a decagon. So decagon is 10. So here's what we're going to do. We're going to first use our equation that you're familiar with now. 10 n minus 2 times 180. This would be 10 minus 2, which is 8, times 180. Okay, 8 times 180 is 1440, but that's the total. It wants to know what an interior angle is. And so if it's 10 sides, I need to divide by 10 so that I can get just one. So divide by the 10 sides, each one is 144 degrees. And this is for the interior angle. Now let's do exterior. Exterior are always 360. We're going to divide by the 10 sides that there are, and that would be 36. So each exterior angle measures 36 degrees. All right, you feel free to try 4, 5, and 6 on your own.